So we are going to dive into inverse trig functions, but before we do, I would like us to take a look at the basic trig functions. And so let's talk about the domain and the range of sine and cosine first of all. Okay, so my domain, really, I'm going to go on, it's going to continue on in both directions. So my domain is all real numbers, sine and cosine both, right? Because I stopped here, but it goes on and on and on forever. And so my domain of this is also all real numbers. So let's think range. So then my range, now I didn't label it up here, but my y values, it's kind of like ping pong here. They go back and forth between -1 and 1. So my range, r, is strictly between 1 and 1. Okay, and the same thing is true of cosine over here, right? This is the same graph of sine, it's just shifted pi over 2, right? So my range over here is also -1 is less than y is less than 1, okay? And it can be equal to because it does in fact equal 1. All right, so let's look at tangent now. Now, tangent, right? This is not quite all real numbers. X, it's mostly all real numbers, except x cannot be, okay? So anytime because this is really sine of x over cosine of x, so anytime that cosine of x is equal to 0, then that's not part of my domain. And cosine is equal to 0 at pi over 2, 3 pi over 2, negative pi over 2. And so I'm just going to write it as x can't be pi over 2. And if you notice, like this is like -1/2, and to get to 1/2, I add 1. This is half plus 1 is 1/2, which is really 3/2. So I'm going to say plus pi k, where k is an integer. So this is the symbol for integer. So basically, as long as k is a positive or negative whole number, then this holds true, okay? But it can be anything else. It just can't be that. Okay, so why do I care about the domain and my range? Well, because, now we're going to talk inverses. So that means when I talk about y equals the inverse of sine is arc sine, it could be written like this, or it can be written as literally arc sine. Okay, now your calculator is going to put it like this, and the book I think alternates between this and this. I really prefer this. For some reason I really dislike this notation because the sign, this is the symbol for inverse, right? But it kind of looks like sine to the -1, and sine to the -1, 1 over sine, is not the same as arc sine or inverse sine. Okay, so let's talk about the domain here. Now, first of all, what has to be true about functions that have inverses? Well, they're supposed to be one-to-one functions, and one-to-one functions mean that they pass the horizontal line test, which this clearly does not. So we are going to restrict its domain so that it does, so that we can still use it, okay? Now again, I want to, when I restrict its domain, have all of the values of range. So basically, I don't want to just restrict it from here to here, right? Because as soon as I turn the corner here, I'm going to pass the horizontal line test, right? So if I just use this part right here, then my y values only go from 0 to 1, and I want all of my y values, right? So I'm actually going to, because if I go any further this way, I'm going to fail the horizontal line test. So I'm actually going to go back down to here, okay? So basically this is what I'm going to restrict my domain to, and this is what we all agree to restrict our domain to. I mean, I know that there's other places on here that do the same thing, but in general, all mathematicians agree that for when we're restricting it for sine, then we're going to strictly, for arc sine, right, then that means that it has to be between -pi over 2 to pi over 2. So we're going to restrict its domain, right? So the y equals sine of x to have its inverse, we're going to restrict the domain to negative pi over 2 to pi over 2. And they can be included because that's where the ones are. Okay? So that means that then when I use this, I can use my inverse function, which is y is inverse sine. Now remember, when I plug in x, when I use y equals sine of x is an angle, right? Or a theta value, right? And y is basically the arc measure. So we put in a theta, we get out a radian measure, okay? And when I'm dealing with y equals arc sine of x, then what I'm going to put in, I'm going to put in the arc measure. That's my x, and my y will actually be my theta value, okay? Oops, sorry about that. Let me move this up. So when I restrict sine of x to negative pi over 2 and pi over 2, it has an inverse, okay? Now, normally when I plug in, my x values are theta values, and what I get out is the arc length, which is really the radian measure, right? Because they're really the same thing. And when I use the inverse, as long as I'm sticking to this domain, right, then my x will be my arc measure, meaning my x will be between, right, up here, remember, our x and y get switched in an inverse function. So that means in this particular case, right, for x, my x will stay between negative 1, oops, I don't know why I did that, negative 1 and 1, and my theta value, my y, my range is all real numbers. Okay? So that's for arc sine. Now, if I look at tangent, tangent is kind of, it's got a very similar restriction. So again, I want to make sure that I get all the top to bottom range values, okay? So as soon as I jump over here, I'm going to start repeating. So I'm going to restrict the domain of tangent from, now I can't use negative pi over 2 because when I do, I get 0 in the denominator. So it's almost the same as where I'm going to restrict sine. It's just that I'm not going to include the endpoints. So for y equals tangent of x, when I'm trying to find, to restrict its domain to have an inverse, it will be from negative pi over 2 to pi over 2 with not included brackets because I'm going to have, these are actually vertical asymptotes at these places. Okay, so we're going to keep tangent to just the middle piece. It catches all the y values here. Okay, so the inverse, right, is y equals, and it's got the same symbol, tangent, inverse tangent, or we can say y equals arctan of x. That's the way we write its inverses. And my, oh, I didn't actually talk about the range, so let's talk about the range of tangent here for just a second. I wrote the domain restriction here, but my range goes from top to bottom, right? So my range is all real numbers. A range, or my domain here, is, we're just going to put an arrow up there, okay? My range will be infinity to infinity. Okay, so then if I'm dealing with arctan, which we say it the same way, or inverse tangent, this can also be written like this, right? The button on your calculator is obviously this button. It's going to have a domain of infinity to negative infinity to infinity because this becomes that, right? And then it's going to have a range where y can't be pi over 2 plus pi k, where k is an element of the integers, okay? As long as k is a whole number that's positive or negative, then this stands true, okay? All right, so for sine and cosine, or sine and tangent, I should say, you know, I'm restricting my domain from negative pi over 2 to pi over 2. Now it's included the endpoints and sine, but it's not included in tangent. But I also like to kind of think of it as the right side of my unit circle too, right? Like this is my generator of all of these values. And this is pi over 2 up here and negative pi over 2 down here. So when it comes to the domain, right, of sine, or the restricted domain, then we're just going to use basically the right side of my unit circle. Okay, so let's talk about cosine here now. So we'll come back up here to cosine. Let me turn my paper here. All right, so my cosine of x, right, y equals cosine of x, I know that my domain is all real numbers, and my range goes from -1 to 1. So that means my inverse, y equals the inverse of cosine, or we say y is equal to arc cos of x. Okay, so this one is going to have a domain of -1 to 1, or I could write it in interval notation like this, right? And my arc cosine, now, this time I can't use negative pi over 2 to pi over 2 because that immediately fails my horizontal line test, right? If I try to draw it in there, I go boop right away. Okay, so again, I want to get all my y values from 1 to positive 1 to -1, and so I'm going to use this piece right here. And then as soon as I hit this place, it's going to turn around and start going back. So that means I'm going to use my restricted domain will be between 0 and pi. Okay? Oh, so I guess I should say, not instead of all real numbers, if I'm going to use it for my inverse, then I will say it goes from 0 to pi here. Okay, so then over here for my arc cosine, that I'm going to restrict my domain will be from 0 to pi. No, it won't. It'll be from -1 to 1. And here my range will be from 0 to pi. Okay, you can write these as an interval, or you can write them in interval notation or as an inequality. But for these, for cosine, right, I think of it as the top half of my circle. So when I'm placing angles and things in my in my unit circle, it helps for me to kind of visualize, okay, well, it has to stay up here, okay? Okay, so we know that when we compose, right, to show that something is an inverse of another thing, then we compose them in both directions. Now, this one's a little bit more complicated, right? So if I have sine of arc sine, this is equal to x, but only if x is in between 1 and -1, okay? Because remember, we always start from the inside, and this has that restriction on it, okay? And so its cosine is the same way. This is the same thing. So because I restricted, my range is the same in both cases of sine and cosine, so my domain is the same when it comes to the inverses. Remember, because we're going on the inside. So my cosine of x, right, because the normal range of cosine is this, then the inverse function has a range or a domain of this, okay? All right, so then we have tangent of tangent inverse is equal to x. And this is good for all x, right? Because here, the domain of arctan inside is all real numbers. So this one doesn't have a domain restriction. Now, if I put them in the opposite direction, sine inverse of x, sine inverse of sine of x, this is equal to x. as long as like I'm staying with my domain restriction here to make my function 1 to 1. So that's if x is between pi over 2 and negative pi over 2, including, okay? Cosine of x is equal to x. I should really put if in there. If, now when I restrict my domain for arc cosine, if x is between pi and 0, remember that was my restricted domain for so that it has an inverse. And my tangent inverse of tangent is equal to x if my x values stay between negative pi over 2, oops, not equal though this time, and pi over 2, because that's our restricted domains, right? We did that based upon we wanted them to pass pass the horizontal line test. All right, so let's kind of look at something here. So let's say that I have arc cosine of pi over 3. Okay, so this is this version, right? And so if this is equal to x, which is here, if x is between 0 and pi. Now pi over 3 actually is between 0 and pi, and so this is just equal to pi over 3. Okay? Now, what if I have cosine of negative pi over 3? Okay? Now, I kind of like to think in terms of my unit circle here. Okay? How do I figure this out? Now this time, right, my x is not between 0 and pi. It's negative pi over 3, okay? So I want to think, where is negative pi over 3? Okay, so negative pi over 3 is somewhere here, right? So it'd probably be about here. Okay, so down here has a positive x and a negative y. Now my cosine is x, so my cosine is going to be positive, okay? So we want to choose, because cosine's domain is restricted to just the top half, right? So we want to pick a value of theta between 0 and pi that has the same x coordinate as negative pi over 3. Okay, so the x is positive, right? So x is positive in this quadrant and x is negative in this one. So it has to be, we want to pick something in this quadrant. And so we're going to choose positive pi over 3 here. So it has the same, so let's see, the cosine of pi over 3 is, this is a half, right? Negative square root of 3 over 2 if I wrote the ordered pair here. And this one up here would be 1/2 square root of 3 over 2. If I was looking over here in the second quadrant, this one over here would be negative 1/2 square root of 3 over 2. And we want the one up here, right? Because there's only two values of pi over 3 up here. So this one would be 2 pi over 3. This one would give me a negative cosine. This one gives me the same positive cosine of 1/2. So this is actually equal to positive pi over 3. Right? So basically, if this isn't between my domain restriction, I want to choose another angle in my domain restriction that gives me the same cosine value. Okay? All right, so let's do a sine. Okay, so what if we have the sine of, let's see, we'll do one more of these. Sine of 3 pi over 4. Okay? All right, now sine, if I come up here, right, so I have sine on the inside, has to be between negative pi over 2 and pi over 2 to be x. Okay, so I'm outside my range again, okay? So if I think of my circle over here, right, 3 pi over 4 is over here. Actually, it's right like here, okay? And this would be the point over here, negative 1 over the square root of 2, 1 over square root of 2, right? And so my sign is actually just limited to pi over 2 and to negative pi over 2 over here. So I want to choose a value whose y value, because sine is the y value, is the same as this one is. And so since it's positive, it has to be up here, and that would be this positive pi over 4 over here, because it has the coordinates, right? So this is pi over 4. Okay. So we'll stop there for right now, and we will pick up in the next lecture.